All right, so before we start this, let's go over some homework questions. Maybe. Let's look at the, number 10 first. So you can see on all my questions, I have little triangles already populated there. That has to be the first thing you do. I know I showed you guys the chart yesterday. Anybody actually liked it? Anybody actually use the chart, or did y'all draw your little triangles? I think little triangles work better, personally. So there are only 4 numbers in this diagram. So start with the little baby triangle, a little small one. That's this triangle right here. So do we have this number?
Yes.
What is that? 1. Do we have this number? No. Because if you look in here, opposite of the right angle, that's the hypotenuse. The hypotenuse is what number? X. So in this triangle, we have 1 and X. It's tough to see. I'll draw that in pink or green or any color but black. We have this triangle right here. And the right angle literally points to the hypotenuse. So here's my right angle right here. It points to the hypotenuse. The hypotenuse is X. Cool. The small triangle's done. Now we go to this triangle right here. Okay, we'll do this one in purple. We have the purple triangle with the right angle right here. So if this is the right angle, it points to the hypotenuse. What is the hypotenuse for that triangle? Y. Do we have a short length or short leg? No, we have a long leg, which is 9. Okay, then for the big triangle, I'll do that one in blue. It points to the hypotenuse. What is the total length of the hypotenuse? 10. Because it's 1 and 9. 1 and 9 make 10. Okay, the short leg, the long leg. So that's how your proportions should be set up. Or that's how your triangle should be set up. Now, you have to solve for 2 variables, x and y. What are the only 2 triangles that have x? The first triangle and the last triangle, or the small one and the big one. So if I use this triangle and this triangle to solve for x, you can do x over its corresponding length, 10, and 1 over its corresponding length. So that's the proportion. And your x's are diagonal from each other, so it kind of gives you a hint that you're right. I'll let you go ahead and solve it. Right? I think you guys can cross multiply and solve that. I think setting it up is more difficult than solving it. So let's go tackle y. What are the only 2 triangles that have y? The medium and large triangle, or the second and third triangle? So you find y, and what is its corresponding length? What's the corresponding length for y? 10. So you do y over 10 is equal to 9 over y. The y's are diagonal from each other, so you can kind of check that you're right. So just it's a long process, and if you get one number mixed up, you're kind of up against the wall. Now, the good thing is for the test, you only have to do it once for 1 letter. You don't have to do all 3 letters and set up like 10 million proportions. Does that make it seem a little more attainable? And it's multiple choice, So if you get an answer and it's not there, like, oh, I probably did something wrong, and you can go back and check your work. So what other questions do you want to see, or did I just do the easiest one? Number 12. All right, here we go. There is only 3 numbers here. So let's start with the small triangle. What do we have for the small triangle? That's this triangle right here. The short leg is 4, and the long leg is 10. There is no hypotenuse. Okay with that? So we look at the medium triangle. Thank you. How long is the short leg now? 10. Look, the 10 is substantially smaller than the x. So we have 10 right here, and the long leg is x. Do I even need to describe the large triangle? Or do I have a proportion I can set up to solve for x? So I can describe the large triangle if I want to. The large triangle, all I have is the hypotenuse right here, which is x and 4, x plus 4. Other than that, I have nothing else. So if I use these 2 triangles, do I have a proportion I can set up and solve for x? Right? 10 and its corresponding length, 10 over x, should be equal to 4 and its corresponding length, 4 over 10. And you notice how the 10s are diagonal from each other and they match? So you should get like 100 equals 4x. And x equals 25. Yeah? Did you have it set up incorrectly on accident?
No, I just didn't know what to do.
Okay, that's fine. There is a never mind. There's a definition in the book. You want to hear it? It says the altitude, or 10, is equal to the geometric mean of 4 and x. Cool, right? So I think my way is a little better, instead of using these really random things. Is there anything else you guys looked at or want to see some more evidence of? Number 15? Pardon?
Which side is longer, like the left side or like right?
On which picture?
Or like just like the actual triangle, like 4x, like on that side, or just the blank?
This one would be the longest piece, this x plus 4, because this is the hypotenuse right here. This is always the longest piece. So I don't call it the longest side, I call it the hypotenuse, because the hypotenuse will never move. 15, is that what I heard? Why does this one seem the most challenging? It's got everything listed. So we have 3 different variables. So just be careful as you're setting things up. I have a short triangle right here. The red one. So try and describe it correctly. How long is the short piece? 8. The long piece? Y. And the hypotenuse? 12. So remember I told you it's always going to be called the hypotenuse, not the long piece. Perfect. And then we get to the medium triangle in blue. What do you think? The short piece? The long piece? The hypotenuse? Z. Because this is the right angle, and the right angle points to Z. This is the right angle, and the right angle points to Z. Alright? And then the big triangle, The large triangle looks like this. The short leg, 12. The long leg, Z. And the hypotenuse, no. 8 and X. 8 and X. What's 2 and 3? 2 and 3. 5. So what's 8 and X? 8 and X. It's 8 plus X. The length, you're adding them together. 2 and 3 is 5. 8 and X is 8 plus X. It goes back to topic 2. That's a segment addition, right? The 8 length plus the X length is 8 and X. It's 8 plus X. I can't change that. Okay, now what.com? Is there something you can solve for? What? You can solve for X. You have 3 variables, and you have to set something up for each one. So is there 2 triangles that both have X? Yeah? The small triangle and the large triangle both have X. So, or y'all are the one that wanted to do this. You have to start struggling through it. What? So if let's try that. We do 8 over 12. So now I have to use the first triangle and the third triangle. Do I want to set up y over z? That's not intelligent. So I'm probably going to want to set up 12 over 8 plus x. Guess what? You can solve that. Do your 12s, are they diagonal from each other? Yes. So you do cross multiply 12 times 12. Cross multiply 8 times 8 plus x. That's 8 times 8, which is 64. And 8 times x, which is positive 8x. Oh, no, math is so exciting. Thank you. So you subtract 64 from both sides. 144 minus 64. 80. Hey, look at that. X equals 10, because you divide both sides by 8. Did we round that number? No, it's at a solid, undisputable x equals 10. So now I can use it. So by x, I'm going to make you 10 now. By 8 plus x, I'm going to make you 18 now. Does that make the problem a little easier to solve? Now I have a legit number there. So what do you want to solve for next? Let's solve for what? You can use this triangle, y over 10 equals 8 over y. That's something you're more comfortable with solving, right? You did long leg over long leg, short leg over short leg. That would work. If you, huh? What? Y over 10? No, you can solve that yourself. I have confidence you can do that yourself. What about z? Let's figure z out. z over 18 equals so just by solving that one complicated measure, we get everything else we can solve for. Like I said, this is the hardest scenario because you're having to set up everything and solve for all three things. All right, I think there's like 2 of these questions on your test. Nothing crazy. Have you gained a little more confidence with this? Yes, ma'am. Go over number 1. Oh, yeah. Number 1. Can I use this page? What are the 2 numbers for number 1?
9 and 4.
9 and 4. So to find the geometric mean, you have to, step 1, multiply. Step 2, take a square root. So we have 2 numbers, 9 and 4. Step 1, multiply. Step 2, square root. There's 2 questions like that on your test. Step 1, multiply. Step 2, take the square root. There's 2 of those. Cool? Alright, so let's get into the new stuff today. Now we're going to look at just proportions in triangles. They are no longer right triangles. They don't have any crazy side angle, side shortcuts. They're just straight up triangles now. This one, I don't know where they got it from. It's called the Side-Splitter Theorem. Sounds legit, right? Sounds like something super official in a math book. So, the Side-Splitter Theorem says if you have a triangle that has 2 sets of parallel lines, you can set up this proportion. Okay, so last time we saw this, you guys saw something that looked like this. Triangle, line, and parallel, parallel. You were able to justify that those 2 triangles were similar because of the alternate interior angle theorem. Now, nobody really cares about the alternate interior angle theorem. Now, if you have a 5 here, and a 6 here, a 10 here, and a 12 here, your proportion is shown to you. You can set up 5 over 10 and 6 over 12. You can do the top over the bottom equals the top over the bottom. That's called the Side-Splitter Theorem. So does it make sense? Is 5 over 10 equal to 6 over 12? Yeah, because 5 times 12 is 60, and 6 times 10 is 60. Their cross products match. So the Side-Splitter Theorem says this piece is proportional to this piece, and this piece is proportional to that piece. It goes top over bottom equals top over bottom. It's a great shortcut to use. Does it kind of make sense? So I'm going to ask you guys today, if you see something like that, say, hey, that's the Side-Splitter Theorem. And then set up your proportion. Alright? And it's just a fancy way to get past another shortcut. Alright, the corollary to the Side-Splitter Theorem says if I have sets of parallel lines and 2 transversals, you can use the Side-Splitter Theorem. So it's called a corollary because it's just a disguised version of the first one. So let me say I draw a parallel line, parallel line, parallel line. Right now it looks like this. And it says that what do you think your proportion is going to be? It's going to be the exact same thing. 2 over 4 is equal to 3 over 6. Guys, it's nothing new because lines go on for forever. It's the same thing we just talked about. They just don't draw the whole triangle. Right? Top over bottom equals top over bottom. It's the last layer. So this is called the corollary for the side-splitter theorem. It's just a disguised version of the side-splitter theorem. So in this scenario over here, we would have 2 over 7 is equal to 3 over x. Then you would cross multiply and solve from there. It will work. It shows you the proportion. It says 2 over 7 is equal to 3 over x. It shows you your proportions. The last new one is called the the triangle angle bisector theorem. If you're going to use this one, you have to see that an angle is being bisected. Okay? To set up this proportion, you use lengths of one triangle over lengths of the other triangle. So you can say 3 over 6 is equal to x over 8. Or you can say 6 over 3 is equal to 8 over x. So the same proportions. That's bisected side over side of the triangle equals bisected side over side of the triangle. So you can use 3 over 6 and x over 8, or 8 over x and 6 over 3. Okay, that's the angle bisector one. Those are the three things that are new. And we're just going to practice that for a hot minute. Okay, it's supposed to be a light day. You ready? So we have option number 1, the side-splitter theorem. Option number 2, the corollary for the side-splitter theorem. Or option number 3, the angle bisector. So let's look at them. All right, what do you see? That's the angle bisector theorem. You see an angle that's bisected. So it's our job to set up a proportion. What over what equals what over what? Okay, so we can use these two numbers. 5 over 2.5 equals 3 over x. Because we went the side of the triangle over the bisected side, so we have to use side of the triangle over the bisected side. Now we just set up and solve. Cross multiply. 3 times 2.5. 7.5. 5 times x. 5x. Divide both sides by 5. And then 7.5 divided by 5 equals 1.5. That's your answer, and you move on from here. So this is the angle bisector example. Okay. What do you see here? You see parallel lines. You see a triangle. So this is the straight up side-splitter theorem. You should see your proportions. What are the proportions that you see? The proportions that you should see are 3 over 1 and x over 1.5. So much easier than right triangles, right? So x times 1, 1x. 3 times 1.5, 4.5. And that's your answer. X equals 4.5. Yeah? So after all of these other things, there is always an easier way. X equals 4.5. So that's using the side-splitter theorem. Number 4. Ooh. What? Is this also the side-splitter theorem? Yes, because remember back in topic 4, if I said if I have two lines that are perpendicular to the same lines, those two lines are also parallel? Yeah. Yes, so these are both perpendicular right here. So because this line is perpendicular and this line is perpendicular to this line, they are described as parallel. So that is a disguised version of the side-splitter theorem. Could you have guessed that and see if it worked? You could probably just guess it. So we see our proportions. This is the side-splitter theorem. X over 4 is equal to 2 over 3. And then you cross multiply and solve from there. So 2 times 4, 8. X times 3. Divide both sides by 3. And you can just leave it like that. 8/3 equals X. Or 2.66666. Doesn't really matter. To save the easy stuff for last. Are you guys experiencing some success with this, or is this more confusing than right triangles? You good? Alright. What do we got here? This is also the side-splitter theorem. What are your proportions? 2x over 15 is one proportion. And then x plus 2 over 12.5 is your other proportion. Yay, I love multiple x's and decimals. The problem that keeps on giving. Cross multiply. Which one do you want to cross multiply first? If I cross multiply this way first, I'm looking at 2x times 12.5. If I cross multiply this way, I'm looking at 15 times x plus 2. Those two things should be equal to each other. So when you multiply 15 times x plus 2, it has to be 15 times x, which is 15x, and 15 times 2, which is positive 30. So that's a distribution problem, right? You have two terms, you have to multiply 15 by both terms. On this side, it's just 2x times 12.5, which is 25 x's. So you need to get all the x's on the same side. Subtract 15x from both sides. Twenty-five x's minus 15 x's is 10 x's. Oh, it's not that bad. Divide both sides by 10. X equals 3. it as bad as it looked? Please, everybody hold your excitement. Alright, last one. Uh-oh. So what's their proportions here? This is kind of the side-splitter theorem, but kind of the corollary, but it kind of doesn't really matter as long as you see your proportions. Doesn't really matter which way you do it. So you're going to use these two numbers together, and you're going to use those two numbers together. It does not matter which way you set them up. I'm going to do 8 over 2x plus 2, and because I went this direction, I have to go this direction. So it's x over 10.5. Cross multiply. 8 times 10.5. Huh? 12? 120. 120. Now we multiply x times 2x plus 2. X times 2x. X times 2x is 2x. X times 2x is 2x squared. X times 2. Positive 2x.
How did you get a 1 and
84?
8 times 10.5.
Is it 84? It's 84? Okay. I just took someone. You're right, 84. Does it make the problem any nicer? Nope. What are we about to do? Solve for x. How do you solve for x? I don't remember. So in this scenario, we have to set one side equal to 0. I have to move this 84 this direction. So I need to subtract 84 from both sides. I know you did this in algebra. It's called factoring. I told you the second semester would get much more glorious. So, because this 2x squared has a 2 in front of it, because the 2x has a 2 in front of it, and because the 84 is even, I can cut everything in half. I can divide everything by 2. Yeah? Good. Make sure you're paying attention. Yes. Yes. So I have a number 1 and 42, 2 and 21, 6 and 7. Those are all the factors of 42. Is there any way I can find two factors of 42 that could possibly add up to positive 1? They have to multiply and make negative 42, but they have to add together to make positive 1. So is there any way that 1 and 42 can make number 1 when you add them together or subtract them? Is there ever any way that 2 and 21 can add or subtract and make the number 1? Is there any way that 6 and 7 can be added or subtracted and make 1? Okay, I need positive 1. They have to multiply to make negative 42, and they have to add to make positive 1. So I have to have a negative 6, and a positive 7. That means my factors are x minus 6 and x plus 7. Because negative 6 times 7 is negative 42, and negative 6 plus 7 is positive 1. So those are factors. They are not answers. Your answers are the opposite of your factors. So if it's negative 6, my answer is positive 6. If x plus 7 is my factor, then x equals negative 7 is my answer. So I get 2 answers for this problem. Double the love. That's just one way for me to feel smart today and make you guys hate an easy day. Will you see it on the test? Absolutely not. No. That's just to give you guys an idea of where it might be going. Cool? Yay. So at this point right now, I'm going to give you guys your assignment and let you work on it for a little bit. Nothing super crazy today. 7th period, you should already have this in your hands.